NASA is working to put Americans on the moon again by 2024. The Artemis program also aims to establish is to use the lessons learned from the moon program.
Since humans first walked on the moon in 1969, the dream of returning has remained alive in our imagination. NASA's Artemis program is not just a mission to visit the moon, it's a bold plan to establish a sustainable human presence there, creating a stepping stone for humanity's expansion into deep space. Combining cutting-edge technology, international collaboration, and a new generation of astronauts, NASA aims to turn the moon into a launchpad for future missions to Mars. Every mission, every experiment, and every technological breakthrough brings humanity closer to becoming a multi-planetary species. Before we dive into the program's goals, astronauts and lunar base plans, subscribe now to follow NASA's journey back to the moon and beyond. Since humans first set foot on the moon in 1969, the dream of returning has lingered in our imagination. The Artemis program is NASA's bold initiative to not just visit, but establish a sustainable human presence on the moon, paving the way for humanity's expansion into deep space. Combining cutting-edge technology, international collaboration, and a new generation of astronauts, NASA aims to turn the moon into a launchpad for future missions to Mars. Each mission, each experiment, and each technological breakthrough brings humanity closer to becoming a multi-planetary species. Before we explore the goals, astronauts, and lunar base plans, subscribe now to stay updated on NASA's journey back to the moon and beyond. Artemis program goals. The Artemis program is designed with ambitious objectives. Its primary goal is to return humans to the lunar surface by the late 2020s, while establishing a framework for sustainable exploration. NASA aims to advance scientific knowledge by studying lunar geology, mapping water ice deposits, and exploring resources that could support life and fuel future missions. The program also serves as a platform to test technologies for deep space exploration, ultimately preparing humanity for Mars missions. Artemis emphasizes international cooperation, enabling shared technological development and resource utilization with global partners. Astronaut selection for Artemis missions emphasizes diversity, experience, and specialized technical skills. Artemis III was an uncrewed test flight, validating the SLS rocket and Orion spacecraft systems. Artemis II will carry astronauts around the moon, testing life support, navigation, and communication in deep space. Artemis III is planned as the landmark lunar landing, which will include the first woman and the next man to walk on the moon. To prepare for these historic missions, astronauts undergo extensive training in lunar analog environments, robotics, advanced spacecraft operations, and long-duration spaceflight challenges. Lunar base plans. A sustainable lunar presence is central to Artemis. The Lunar Gateway, a modular space station orbiting the moon, will serve as a hub for crew rotations, scientific research, and docking of lunar landers. On the surface, modular habitats are designed for long-term human habitation, enabling astronauts to live, work, and conduct research for extended periods. Lunar resources, particularly water ice, will be used to produce fuel, oxygen, and life support essentials. Advanced rovers and autonomous systems will assist in transportation, construction, and scientific operations, allowing for safe and efficient lunar exploration. The Artemis missions rely on powerful spacecraft and rockets. The Space Launch System, SLS, is NASA's most capable rocket, able to carry Orion spacecraft, astronauts, and cargo to the moon. The Orion spacecraft is designed for long-duration missions with advanced life support, radiation protection, and navigation. Systems. Redundant systems and rigorous testing ensure astronauts' safety from launch through lunar orbit and landing. These technologies are the foundation for NASA's long-term lunar exploration and serve as a testbed for interplanetary travel. Scientific and technological goals. Artemis missions will advance science and technology in multiple ways. Lunar geology studies will expand our understanding of the moon's history and resources. Experiments on human health in low gravity will prepare astronauts for Mars. Energy systems, autonomous robotics, and communication networks developed for Artemis will support extended lunar habitation and future deep space missions. By combining exploration, research, and innovation, Artemis sets the stage for sustainable space exploration. Artemis relies on global partnerships to achieve its goals. NASA collaborates with agencies such as ESA, JAXA, and CSA, as well as private companies to share knowledge, technology, and infrastructure. NASA's Artemis program aims to return humans to the moon and build a sustainable presence. The Lunar Gateway and surface habitats will support long-term stays, using water ice for fuel, oxygen, and water-advanced rovers. Autonomous systems and next-gen technologies ensure safe exploration. Each mission tests life support, robotics, and precision landing, paving the way for permanent lunar bases and future Mars missions. This approach reduces costs, increases safety, accelerates innovation. By creating a model of international cooperation, Artemis not only returns humans to the moon, but also establishes a framework for global collaboration in deep space exploration. Artemis mission. Timeline. The Artemis program follows a meticulously planned sequence of missions to ensure safety, technological validation, and progressive expansion. Artemis 1 served as the uncrewed test flight, launching the Orion spacecraft atop the Space Launch System (SLS) rocket to orbit the Moon and return safely to Earth. This mission validated the performance of critical systems including propulsion, guidance, communication, and life support redundancies. Artemis 2 will be the first crewed flight, sending astronauts on a lunar flyby to test Orion's life support, navigation, and operational readiness under real deep space conditions. The highlight, Artemis 3, is scheduled to land astronauts on the Moon's south pole, including the first woman and next man, marking humanity's first lunar landing in over 50 years. Subsequent Artemis missions aim to establish a sustainable presence, with repeated landings, extended stays, and deployment of infrastructure. Each mission builds on the last, gradually transforming temporary visits into a permanent foothold on the Moon. Lunar landing strategies and exploration routes. Landing on the Moon is far from trivial. NASA has chosen the South Polar region for Artemis 3. Due to its unique combination of permanently shadowed craters containing water ice and regions of near-constant sunlight for solar power. Advanced landing systems, including precision-guided engines, hazard avoidance sensors, and autonomous terrain mapping, ensure a safe touchdown on uneven and unpredictable surfaces. Exploration routes are carefully planned to maximize scientific value while minimizing risk. Astronauts will traverse diverse terrains with advanced rovers, collecting geological samples, deploying scientific instruments, and testing new technologies for in-situ resource utilization. Autonomous drones and robotic systems will assist in scouting, cargo transport, and habitat assembly, allowing humans to focus on high-priority research and complex construction tasks. Sustainable lunar habitation requires cutting-edge engineering. Artemis habitats are modular, expandable units designed to provide life support, radiation shielding, and thermal regulation. Interior designs incorporate laboratories, living quarters, storage, and command centers. Surface operations include assembling habitats, installing energy systems, and constructing resource processing facilities. Water ice extracted from lunar regolith will be converted into fuel, oxygen, and drinking water, forming the foundation of long-term survival. Solar arrays and nuclear power systems provide continuous energy, while communication networks maintain contact with Earth and the Lunar Gateway. These systems are tested under extreme conditions to ensure astronauts can survive months on the Moon. Advanced technology development. Artemis serves as a testbed for next-generation space technologies. Autonomous robotics handle repetitive or hazardous tasks, reducing risks to astronauts. Advanced rovers provide mobility across rough lunar terrain, while drones and sensor networks survey regions inaccessible to humans. Life support systems are designed for efficiency, recycling air, and water in closed loops. Energy solutions combine solar, nuclear, and thermal technologies to maintain stable power. Orion spacecraft's radiation protection systems are crucial for extended exposure to cosmic rays. These innovations are critical for the Moon and will inform designs for Mars exploration, deep space habitats, and future interplanetary travel. Scientific research drives Artemis missions. Astronauts will collect rock and soil samples to study the Moon's formation, evolution, and mineral composition. Water ice in permanently shadowed craters will be analysed for its potential use in fuel and life support. Experiments in human physiology will study the effects of low gravity, radiation, and long-duration space habitation, providing essential data for Mars missions. Astronomy and space weather experiments will be conducted from the surface, taking advantage of the Moon's stable platform and minimal atmosphere. Artemis is designed not only to return humans to the Moon, but to expand knowledge in geology, chemistry, biology, and physics. Lunar Gateway operations. The Lunar Gateway is a central component of Artemis. Orbiting the Moon, it functions as a staging point for lunar landings, a research platform, and a hub for international collaboration. It allows astronauts to transfer between Orion and landers, conduct experiments, and store cargo. The Gateway also enables modular expansion over time, supporting additional crews, advanced research modules, and future Mars mission simulations. This orbiting station reduces the complexity of surface operations and provides a safe fallback in case of emergencies. NASA is partnering with international agencies such as ESA, JAXA, and CSA, along with private companies to pool expertise, resources, and technology. ESA contributes habitation modules and service systems for the Gateway, while JAXA and CSA provide robotics, research equipment, and communication technologies. Private companies assist with landers, habitat construction, and supply chain logistics. This collaborative framework not only reduces costs, but accelerates innovation, ensures safety, and strengthens global ties. Artemis demonstrates that space exploration is no longer solely a national endeavour, but a global mission requiring shared vision and resources. Mission challenges and risk management. Operating on the Moon comes with immense challenges. Astronauts face extreme temperature variations, high radiation exposure, low gravity, and abrasive lunar dust that can interfere with equipment. Technical challenges include reliable rocket launches, precise landings, habitat sustainability, and robust life support systems. Artemis mitigates these risks through extensive testing, redundant safety systems, astronaut training, and advanced robotics. Each mission builds incremental experience, gradually reducing risk and refining operational procedures for long-term habitation. Artemis is not just about the Moon. Every mission is a rehearsal for human exploration of Mars. Technologies validated on the Moon, such as closed-loop life support, in-situ resource utilization, autonomous robotics, and advanced habitats, will be adapted for Martian conditions. Crew training in extreme lunar environments prepares astronauts for the challenges of long-duration interplanetary travel. Artemis establishes the knowledge, infrastructure, and confidence to enable humanity's next giant leap, living on another planet. Inspiration and public engagement. The Artemis program inspires millions around the world. It engages the public through media coverage, education initiatives, and interactive experiences that showcase the complexity and ambition of lunar exploration. By returning humans to the Moon and advancing science, Artemis motivates new generations of engineers, scientists, and explorers to pursue careers in space technology, research, and innovation. Public involvement ensures continued support and enthusiasm for humanity's journey into deep space. Beyond initial missions, Artemis aims to establish a permanent lunar base with multiple habitats, laboratories, energy systems, and resource processing facilities. These bases will support long-duration scientific research, commercial opportunities, and international collaboration. The Moon will become a hub for testing Mars-ready technologies, life support systems, and energy networks. By creating a permanent foothold, Artemis ensures that humanity's presence in space is sustainable, scalable, and capable of supporting interplanetary expansion. Outro: the Artemis program represents humanity's boldest step into the future since the first moon landing. With astronauts returning to the lunar surface, habitats and infrastructure taking shape, and global partnerships driving innovation, NASA is redefining what is possible in space exploration. Artemis is more than a mission. It is a vision for humanity's survival, growth, and adventure beyond Earth. Subscribe now, hit the bell icon, and follow every launch, every experiment, and every milestone as NASA turns the Moon into a gateway for Mars and the stars. Witness history in the making. The future of human space exploration is happening now, and you can be part of it. And the Artemis program represents humanity's boldest step into the future since the first moon landing. With astronauts returning to the lunar surface, habitats and infrastructure taking shape, and global partnerships driving innovation, NASA is redefining what is possible. In space exploration, Artemis is more than a mission. It is a vision for humanity's survival, growth and adventure beyond Earth. Subscribe now, hit the bell icon, and follow every launch, every experiment, and
This is Apollo Saturn launch control, T-minus 3 hours, 4 minutes, 32 seconds and counting.
every milestone as NASA turns the moon into a gateway for Mars and the stars witness history in the making. The future of human space exploration is happening now, and you can be part of it.